Hi everyone. Today we are going to solve this interesting problem. We have a sorted array, like a sorted array, and we have to convert that sorted array to the binary search tree. And as you know, sorted array and binary search tree has highly coupled things. So we have to create a binary search tree from the sorted array. So the question is really straightforward. We are having the array and we have to return the root of a binary search tree. That's all. So look at the constraint and you can see the nums is already into the strictly ascending order. So that is clear. Cool. We can just directly jump on like how can we solve this problem? Suppose. First of all, what is BST? First question we should ask is what is BST? So BST, binary search tree, is a tree where every node has a higher value than every node into the left subtree and smaller value than the right subtree. Suppose like what is a BST? Let me write this down. Every subtree is a BST and root node, or I would say like a largest node into the left subtree is less than largest node in left subtree is less than root is less than smallest element in right subtree. So that is a clear-cut definition regarding what is a BST. Now let's take one example. How can we get the BST? Suppose this is a minus 10, minus 3, 0, 5, 9. This is the same example which we have into the question. Now assume we took the mid as a 0. So if we take a mid of a sorted array strictly into the ascending order, so elements into the left side will be always less than the mid and elements into the right side will always be greater than the mid. So in this case, these are the left and right array minus 10, minus 3 and this one be 5, comma 9. So until this point it is clear, right? Now if we took a mid of a this, so suppose this is a minus 10 and this is a 5, like a 0 1, take a mid, something like that. And after that, can you guys see like a left and right of both the nodes? Here left to the minus 10 is nothing, left to minus 10 is nothing, and right to the minus 10 is a minus 3, and for 5 left to the 5 is nothing and right to the 5 is 9. Cool. Again, as we have nothing here, so we can just return null, or here can we say this will be a minus 3 and this will be a 9, and left and right subtree for both of them will be empty arrays. So is this diagram clear to you? We found the mid and all the elements into the left part is smaller than the mid and vice versa. And again we found the mid, we repeated the same procedure for the subparts until when we have the empty array. So how can we solve this? Let me copy this. can we say, so this is a 0, 1, 2, 3, and 4. These are the indices of an array, and mid will be 2. So we took a mid and we created a node, okay, and then we recur for the left subtree. So this is a left subtree, and then we recur for the right subtree. Here for left subtree, this is a indices 0, 1, and for right subtree, these are the indices 3 and 4. Until this point, it is clear, right? We found the mid, we recurred for the left and right subtree. Now here, figure out the mid 0 plus 1 divided by 2. Here, figure out the mid 0, 3 plus 4 divided by 2. In this case, here value of a mid will be 0, and here value of a mid will be 3. Can you see this? And for the mid value, we have created a node, and in this case, this will be get attached to the parent left. This will get attached to the parent right. Again, then we have recurred for the left subtree. Here it is empty, and here also it is empty. At the right, we have increased. Suppose here, I would say the indices will be 1, comma 1. In this case, value of a mid will be 1, and here the value of a low and high is 4, comma 4, and value of a mid will be 4. So can you figure out some algorithm on this? So we have the array, we have to figure out the mid. After finding the mid, we have to create a node, and then we have to recur for the left subtree, and we have to attach the root of left subtree to the right of the node, and then same process for the right subtree. And the base case, whenever, like this is the base case, this is a base case. Suppose here low, like low is a 0, high is a 4. Here low is a 0, high is a 1. In this case, here low is a 0 and high is mid minus 1. In this case, high equal to minus 1. So base case would be whenever low is greater than high, then return null. So this is the base case. This point it is clear, and we can just write down the algorithm. So base case, if low is greater than high, then return null. Again, if a base case is not satisfied, then we have to figure out the mid, then figure out the mid, then create a node for the mid value, create a node having mid, or I would say value on mid index, then recur for left subtree, left subtree would be from low to mid minus 1, and attach to node dot left, and same recur for right subtree. Right subtree will be from mid plus 1 to high, mid plus 1 to high, and attach to the node left, attach to, sorry, node dot, and then return node. Okay, so this is the algo. So we will check once again what is a BST. We have understood that. Then we have understood by figuring out a mid, we can just segregate the smallest part than mid, largest part than mid. After that, we have figured out using indices low and high. How can we just figured out a base case? How can we recur for left subtree and right subtree after figuring out the mid value? And this is the algorithm. So what will be the time complexity for guys? Time complexity, that will be O of n, because we are visiting each element once, and space complexity will be also O of n, because if I would say, to be more specific, space complexity will be O of a height of a tree, because while creating a tree, height of a tree can be the number of calls into the stack trace. So that's all regarding this problem. Let's try to code this. If you have any more doubts, please feel free to drop a comment on the video. Now this is the question. We have to solve this. First of all, add a base case. If a array has a 0 elements, then return null. That is the first thing. Again, then return, create a function, get or generate BST, which will get a nums, which will get a low. Value of a low at earliest point is 0, and value of high is a length of nums minus 1. Now again generate BST, def generate BST. So this is nums, this is a value of a low, this is a value of a high. After that, there is a base case as we have discussed. Low, if a low is greater than high, then we have to return the null. Low is greater than high, then return none. Now we have to figure out the mid. Low plus high divided by 2, and after figuring out the mid, we have to create a node. So node is a tree node, so that's how we can create the node with the nums of a value on the mid index. After that, we have to recur for the left subtree and right subtree, and we have to attach those to the node dot left and right specifically. Node dot left equal to generate BST. This is a nums. How can we get recur for the left subtree? Low to mid minus 1, and node dot right will be generate BST. How can we recur for the right subtree? Mid plus 1 comma high, and at last return the node. Let's try to run this. Yeah, it is working fine. Let's try to submit this. Cool, it got submitted. So that's all regarding this problem. We have understood the BST, how can we convert this, and all this stuff. We have understood time and space complexity also. Okay, chalo, bye.